Welcome back. Previously we have started the concept of set theory and we have briefly discussed various terms and concepts with regard to set theory. Today let us discuss about the graphical representation of set theory. Representing sets through a graph is known as Venn diagram. The concept of graphical representation of sets was introduced by a great mathematician John Venn. That is why it is known as Venn diagram. So how we are going to represent the sets in a diagram, that too graphically. So the representation of sets is known as Venn diagram. Let us discuss in brief regarding various sets which we have learned. Theoretical concept we have learned previously, and we can represent those in a graph with some simple examples. I hope this is the theoretical part which you will be find in your text. At the initial glimpse you may find it confusing because in this explanation they have given somewhat detail, and at the same time they are not giving any introduction details. So without any preliminary information you won't be able to get a clear picture regarding these details given in the text. So I will try to give a glimpse into this area. Regarding further aspects we will discuss in future. First one, I will be explaining each one with an example. Complement of a set. Previous class we have discussed that area. Complement of a set. Complement means anything that comes only to that particular set but it doesn't belong to that universe. That is known as complement of a set. For example, in this figure, this is known as the example of a complement of a set that can be represented graphically. I have mentioned in the previous class, set is usually represented in a rectangle shaped figure. This entire area is known as universe. Whatever that comes within this universe is represented in the form of sets. And here you can see that a circle, and within which it is written A. Set is always represented by a circle, and within that circle there will be an alphabet that will be the name of that particular set. Complement of a set means anything that comes to that particular set. Here particular set means A, but it doesn't belong to the universe. If you look closely you can see that there is a line that is drawn very close to each other, but it doesn't touch the inside of the set A. That means this set is a complement means this set doesn't belongs to universe. That is why the line doesn't crosses the set A. You will get a clear picture with another example. In this picture you can see that here, see, don't go for this explanation part, just go very closely to this picture. Here E is represented as the entire universe. E means all the alphabet letters except vowels, and you can see that O is the name of the circle set. O means all those vowels. We know that vowels include A, E, I, O, U, and E includes all those alphabets except vowels. So you can see that all the alphabets except vowels are written outside and the vowels is written within the circle. So this circle is represented by the complement. I hope you have got a clear picture regarding that. Let us go to the next part. And previously we have learned the equation A raised to C. A raised to C can be used, or A raised to dash. A raised to C means complement. It is represented by U minus A. Next one, set. We all know what is meant by set, and let's see how it's going to be represented. See, this is an example of a set. Rectangle, it is represented by the sign U. U means universe. A is a set of U, and you can see that A is shaded. It means A is shaded and A is the part of the universe. Next one, subset of a set. Previously we have mentioned means subset means anything, a set that comes under a main set. If you look closely this picture, see this picture, there is a rectangle. Within that there is a one circle which is represented by A, another circle represented by B, and you can see that all the circles are lined. It means the meaning of this picture is B is the subset of A. In other words, all those elements of B is also there in bigger set known as A. That is the concept of this picture. Next one, disjoint sets. In the previous class we have discussed the concept of disjoint set. Disjoint set means two sets who have no sort of similarity with the elements. This is an example of a disjoint set. Here there are two sets within the universe, and these two sets are not joined together. That is why it is known as disjoint sets. Next one, union of two sets. Previously we learned the concept union of two sets means all those elements of A and B are combined together is known as union of set. See, this is an example of a union of set. If you look closely, you can see that set A and set B are connected and these two circles are lined together. The meaning of this picture is union of sets. And there is an equation regarding that. Union of set equal to N is represented by the figures bracket A union B equal to N of A plus N of B. N of A means all the items of A plus all the items of B minus N of A intersection B. You may find that equation confusing. The thing is that here the union of set means all the items of A and all the items of B. So when it is represented in the equation, it means all the items of A, all the items of A means C of A and all the items of B. And if you go through these figures very closely, you can see that there is one area in which that is common to A as well as common to B. So when you add together all these, we need not have to include this area to be added twice, because when you take all the items of A like this area is also taken. When you take all the items of B, again this area is also taken. That means this particular area is taken twice. We need not have to take that area twice. So this area is represented by the term which we have learned in the previous class, that means intersection. Intersection is represented by A intersection B. So when union of set is represented through a graph, its equation is N A union B equal to N of A plus N of B minus N of A intersection B. That is the concept. I hope you have understand the concept. I will give another example with regard to that, then you will get a clear picture. See, you can see that here is another picture where this rectangle is represented by universe. For the time being, this E is used as a universe. You can see that A and B are two sets, and its union is represented by all these sets. If you are representing a union, remember I have explained that concept previously. If you are adding to the equation was that all the items of A plus all the items of B minus intersection. That was the equation. How did that happen? See, all the items of A means 1, 9, 6, 3, 5, 2. Okay, number of items is 1, 2, 3, 4, 5, 6. So it can be written as 6 items. So A intersection B is 6. Again, all the items of B include 1, 2, 3, 4, 5, 6, 7. Do we have to take these 3 numbers again when you are representing all the items in a sets? No, we need not have to take. So in that case, you need to take like this. 6, 9, 1, 2, 5, 3 and 8, 10, 7, 4, 2, 5, 3 and you will get 6 plus 7, and out of that if you deduct these three you will get the exact figure. So A union B is all the items of A plus all the items of B minus intersection, number of items in this intersection. That was the equation which we have discussed now. You need not have to go all these items in detail. We have to go to further areas with relating to our syllabus, but for the time being, for understanding purpose only, we are going further like this. If you want any further explanation, you can contact me. So let us go back to our syllabus. I hope you understand the concept of union of two sets. Next one, intersection of two sets. We have discussed that area just now. Intersection of two sets means this is an example of intersection of two sets. See, intersection means anything that is common in both sets. If these two circles are joined together like this, the common area for both the two circles is this one. This area is known as intersection, and we have discussed this intersection part just now, and in the previous example we have mentioned this area also. So that is known as intersection. And finally, difference of two sets. In all these examples we are using A and B, that is why here written A minus B. I hope you know the concept of difference between two sets. A minus B means all those elements in A is only taken and not the all elements of B. So it is always represented by like this. See, here A and B are two sets that are joined together. And one more thing, always sets circles will be drawn like this. One circle will be drawn like this, another circle which will be slightly over the another one. All the sets are represented like this except in case of disjoint sets. See, these two are the examples of disjoint sets. See, and in the theoretical part we discussed that difference of two sets means all those items in A is taken and neglecting all the items of B and common in B. So the figure will be represented like this, only taking all the items that is presented in A. We will not draw lines in here because this area includes B also. So this is how you need to represent difference of two sets. So these are some of the major theoretical aspects with regard to that. We will discuss in future regarding anything relating to this. If you want any further explanation regarding any of the points, please contact me. We will go with the further theoretical aspect regarding our syllabus in the next sessions. So let us go to the next area. Permutations and combinations. It is also in a mathematical area which we will be using in the day-to-day business application. So before we go into that, you need to understand the concept of permutation and combination. So before we go further into the permutation combination concept, you need to familiarize some terms and functions with regard to mathematical operation. First one, factorial notation. You will be dealing with factorial notation in numerous situations in future. Factorial notation is the continued product of first n natural numbers is called factorial notation, which is represented by the sign n, and it is denoted by n an exclamation mark. This is known as factorial notation. From here on we will be using the name factorial notation for this sign, or it can be otherwise known as, it is not the less than one, it is actually a sign just like this, angle sign, angle n. So we will be using in the equations and problems n factorial notation. or sometimes it can be called as n factorial. N factorial means whatever any number after this sign means anything that comes before the number. For example, 5 factorial, 5 after 5, if you are writing this sign, it means 5 after that you will be taking the multiplication of all numbers preceding 5. That means 5 into 4 into 3 into 2 into 1. That is the meaning of any number factorial. N factorial means that. If it is 10 factorial, that means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That is the meaning. For example, 8 factorial means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And the entire product number is known as factorial notation. So let us go to permutation, because one of the major functions which we are using in permutation is this factorial notation. Not only in permutation, we will be using the factorial notation in combinations also. So what is the meaning of permutation? The number of different arrangements that can be made by taking some or all the items are called permutations of those items. Simple meaning means if you are given some letters or numbers, and if you are given a chance to take any number of items at a time, and you are asked to create number of formations that can be made or number of arrangements that can be made, that is known as permutation. You will get the clear picture with an example. Anyway, the equation of permutation is n, capital P is represented by permutation. Here n means total number of items in that particular item which you are under study. R means you can take or choose number of items at a time. Means if you are given 5 numbers, if you are asked to find the number of combination out of 2 items taken at a time, so R is represented as 2 and n is represented as 5. You will get a clear picture with the example. And the equation for NPR is n factorial divided by n minus r whole brackets factorial. The equation may find it confusing, but the real example, practical example is very easy. For example, you are asked to find 7p7. 7p means 7p7 has to be represented like this, but the easiest method for finding the permutation is 7p7 means you need to take 7 from 7, you need to take 7 items preceding the 7. So 7 into 6 into 5 into 4 into 3 into 2 into 1 and take their product. This is known as an example of a permutation. If you write the same values in this case also, you will get the exact answer, but this is the easiest method for finding the permutation. So with another example you will get a clear picture. Here 6p2, that means see here 6 is the n, total number of items. From 6 you need to take the numbers that is preceding 6. So 6 into 5 into 4 into 3 into 2 into 1. We have learned that concept, but remember here it is given 6p2. That means you have to take only the preceding 2 points. That is 6 into 5. See, 2 items. Take their product. This is known as permutation. Permutation means number of arrangements that can be made on the basis of those items that are taken at a time. In this case, out of total 7 items, you can take entire 7 items at a time. But here, out of 6 items, you can take only 2 items at a time. So that is the concept. See, 6p0. 6p0 means 6. So from 6 you have to take the preceding numbers. But here it is given 0. So note that this is a rule. Any number factorial means 1. So answer is 1. So this is how you need to find the permutation. I hope you understand the concept of permutation. This permutation is almost similar to factorial notation. In factorial notation, any number factorial notation means you need to multiply all the numbers preceding the given number. But in case of permutation, remember here also same concept, the number preceding all preceding numbers of the given number is taken. But remember 7p7, in this case 7 is given, another 6p2, here 2 is given, means number of points that can be taken. You need to consider that aspect in case of a permutation. Let us discuss some other example. How many words can be formed with the letter word Rajesh? Rajesh means from these letters how many words can be formed. And in this case they are not mentioning about how many letters that can be taken at a time, so nothing is mentioned here, so we can assume that 1 2 3 4 5 6 letters are there. How many words can be formed if you are taking 6 letters at a time, if you are taking all the letters? So the answer is total number of items is 6. 1 2 3 4 5 6. Here there is no mention in regarding how many items that can be taken, so we can assume that all the letters can be taken at a time, so R is 6. So therefore the number of arrangements can be taken, number of arrangements that can be taken means permutation done means NPR equal 6p6. See, 6 into, from 6 any all numbers that are preceding this 6 can be taken, so 6 into 5 into 4 into 3 into 2 into 1, 720. See the difference between 6p6 and 6p2. Here we have taken only 6 into 5 because here it is given you can take 2 digits at a time. Here it is given 6 digits at a time, so 1 2 3 4 5 6. That is the concept. I hope you understand the concept. Try to identify more examples or cases with regard to permutation case, and remember this is just a concept that will be used in some of the essay questions which we are going to study in future. So understand the concept of permutation. We will discuss about the further cases in the next session.